Good afternoon. I'm Li Hehao from Shanghai Jiao Tong University, China. I'm here to present certified copy understanding security risks of Wi-Fi hotspot-based Android data clone services. This is a joint work with Dr. Siqi Ma from the University of Queensland, Professor Sylvia Nepal from Cicero, and Professor Elisa Pertino from Purdue University. Let's start with an overview of data clone services on Android devices. Users upgrade their mobile phones in about a year or two, and they also want to copy user data from the old phone to the new phone. As mobile phones are becoming more and more powerful, not only SMS messages and contact information, users also prefer to copy photos and app data. Hence, a variety of data clone services are developed. The most common way to clone user data is using services such as iCloud and Google Cloud, through which users can copy data to a third-party cloud server and then transfer those data to the new phone from it. There are also other transmission channels to help users clone their data, and data can be transferred between two mobile phones directly. We compile 3 common ways to clone user data. A cloud-based data clone only works online, and its speed is slow. A USB-based data clone needs the help of a personal computer or a laptop. In this paper, we focus on a Wi-Fi hotspot-based data clone. It relies on end-to-end data transmission channel between two mobile phones to fulfill the data task, which is convenient and simple and becomes very popular these days. However, we found popular Wi-Fi-based data clone services suffer from particular risks. These services are often implemented by Android device manufacturers, and they can operate many types sensitive data that a user app cannot access. For example, a data clone service can back up and restore app data in sandbox. This actually violates Android security model. So, the purpose of our study is to investigate whether popular Android data clone services securely handle user data. In this part, I will detail how to analyze Android data clone services and detect potential security risks. A data clone service often takes 4 steps to migrate data between two phones. First, a temporary Wi-Fi hotspot is created by one phone, and the other one joins the network. Next, a backup thread on the old phone retrieves user data and packs them into intermediate files. As soon as a file is packed, another thread sends it to the new phone. When the file is received by a receiving thread on the new phone, a data restoring thread unpacks and imports the files. To detect implementation flaws, we first examine the setup of the Wi-Fi hotspot. We check generation rules of Wi-Fi SSID as well as WLAN password in data clone apps. In addition, we check whether the hotspot allows more than 2 devices to join in. We argue that a data clone service should allow only 2 Android phones to join the same WLAN simultaneously, and a third WLAN connection request should be declined, even if the correct Wi-Fi password is provided. After the Wi-Fi network is established, we further examine how the data clone app accesses user data. We reverse engineer the data clone app and relevant system services to understand the data access behaviors. For example, to understand how various kinds of information are exported and imported, we first monitor file I/O operations to identify where the intermediate data are stored and check whether these intermediate data are properly cleaned after transmission. Then, we monitor the invoked system services and system components to understand how data clone app retrieves system data. Finally, we identify exposed components of this data clone app and verify whether they can be exploited by malicious app. Besides on-device operations, we also monitor network traffic and identify the used protocols, which often includes HTTP, FTP, or other vendor customized protocol formats. For customized protocol, we reverse engineer the data clone app to understand their formats. Finally, we actively tamper the transferred data to check whether the transmission proves confidentiality and integrity protections. Following the previous analysis, next, I will present our investigation results of 8 popular data clone services and report our discovered security flaws. To automate the analysis, we designed and implemented Poirot, an analysis system with 3 components: a stack code analyzer to reverse engineer the data clone app, a dynamic instrumenter to monitor the data clone processes at runtime, and a network inspector to inspect network packets. With Poirot, we can easily analyze the data clone service. We connected data clone services of 8 popular Android manufacturers as experimental targets. These data clone services are integrated in off-the-shelf Android phones released during 2015 to 2019. And the Android systems installed on these phones ranged from version 5 to 9. In short, we found 7 out of 8 data clone services suffer from security threats due to 3 aspects of weaknesses. Data clone services tend to use insecure Wi-Fi networks and data transmission protocols, and the temporarily generated files during the data clone process are often exposed to attackers. In this situation, both network-level and on-device attacks could be conducted to obtain sensitive user data. We found most data clone services don't use a secure Wi-Fi network to fulfill the data clone. Many of them use predictable SSIDs, which are easily detected by attackers. Almost a half of the investigated services don't generate password randomly, allowing attackers to join the W line without authorization. What's worse, only Huawei service restricts the number of devices connected to the temporary W line. We found that none of them used encrypted communication when transmitting data. In other words, they only rely on encrypted network to guarantee data confidentiality. Therefore, data eavesdrop attack is feasible on phones with insecure network. We also identified a logical error in verification of Xiaomi's service. Even if the data don't pass the verification, it can be restored normally. In other words, once the private network is exploited, they face data tampering attack. A highly critical security flaw we found among those data clone services is that they tend to store user data as intermediate files on SD card. These files are not properly protected, and malicious third-party apps with external storage permissions could copy these files and obtain sensitive data. Although These intermediate files will be deleted after the data clone process. There is a relatively long time window for malicious applications to copy files. We have implemented this data extraction attack on 4 Android phones. We have reported the discovered vulnerabilities and the consequences to the corresponding manufacturers, and the manufacturers has recognized the vulnerabilities and fixed them. Finally, let me summarize this work. To understand the security of widely used Wi-Fi hotspot-based data clone services, we built an analysis system to examine the code implementations of these services and detect flaws. We found 7 investigated data clone services are vulnerable to both on-device attack and network-level attack, and millions of Android phones with these services are affected. We have reported these flaws to involved manufacturers and helped them fix the issues. Thanks for listening.